Hello everyone, this is Stas, and today we're gonna talk about colors and the color palettes, and especially generative or procedural color palettes. And I decided to divide this tutorial into two parts because sometimes it's really difficult to start watching some 1 hour long tutorial. So I decided to make a too shorter one. And in this part we mostly talk about the theory behind the generative color palettes, so you don't need to code anything today, so you could sit back and relax and just watch it. And second part would be released very soon, and it would be about the practical stuff, how to use these palettes in different scenarios, like in instancing, in something simple like lookups, in colorizing particles, maybe fractals, conformal mappings, in ray marching, in GLSL math, and so on and so on. So, what is generative color? What I mean by that? Sometimes you don't want to pick every color for your work manually, and you want to make or to have some algorithm to do it. And maybe your first idea would be to use the noise and make it something like 50 by 1, so you have this nice gradient, and make it non-monochrome and increase the period. And sometimes you can get nice gradient, but it's not always the case. Sometimes there is, for example, this one, the contrast of the colors, the difference between, it's not very much, it's not good much between those colors, because this is just random colors. Well, the Perlin noise, it's a little bit better, but still, and sometimes the colors are too blunt, sometimes they are too dark or too bright or too contrast, so the noise isn't a very nice option. Next, if you need 2 or 3 colors, is the simplest solution would be, and this is my very effective solution and I used it a lot, is to go into some website, for example this colorhacks.com and many others with a similar idea, with a collection of nice palettes. And you could click on some palette or search. For example, I like this Starry Night palette, and you have the values, so you could easily use these numbers in your file. But very often you don't you need not 5 colors, but you need the gradient, because the gradient is much more useful in many scenarios. When you have a range of data and you want to colorize this range with a nice gradient. And so what could you do? One of the easiest solution is to find the good gradient palettes. For example, this quite famous Viridis color palettes. I will leave the link in the description. You could read about these palettes, and it's widely used in many infographics for colorizing like heat maps, or some infographics like this population or unemployment and so on and so on. Very nice palettes, and because it's widely used, many people are very familiar with these colors, and they easily understand that the brighter pixel is, the more it's orangey, yellowish, the bigger the value. So you don't need any legend or explanation. Very nice colors. And here I implemented in TouchDesigner. I took the colors itself from this shader and luckily it's a license Creative Commons 0, which means that you could use it in any of your works, including commercial. So it's freely available. And by the way, all this file would be available on my Patreon for everyone, not only for my patrons, but for everyone. So probably it's better just to go and download it, so you can follow me in some parts by looking into the file. Okay, here I have four Viridis, different Viridis palettes, and another nice one which is quite commonly used for representing some fire colors. How is it organized? Here we have just two variables. One is the time and the second is the frequency. Frequency, as you might guess, is how much time you want to see this palette inside this width, inside this resolution. And the default is 0.5, so 0.5 is a full palette repeated only once. And with the time you could use something like Epps times seconds multiplied by something, and so this palette would be scrolled and scrolled and scrolled. And if you go inside the GLSL code, it's mostly just a ramp, because if you ever did your ramp, if you pick some, if you pick some ramp colors, some more ramps, and if you press this button, you will have almost the same data as here. So why not to use the ramp instead of this GLSL code? Well, first of all, you could use ramp. You just will need to find the color codes for every color and make your own ramp. But sometimes it's better to have it inside GLSL. For example, let's say you have particles, and the particle would have, for example, a speed or velocity, and you want to colorize this velocity. And if you just connect a ramp into your GLSL particle, you have two options. You either want to smooth interpolation between all of these pixels, and then you need to set input smoothness as interpolate, or because it's particles, probably you want exact position to have a right calculation, and that's why you need nearest pixel. And you can have both options in once. So the solution for this is to implement this palette inside GLSL. But you could use this already pre-made GLSLs as a ramp for your, for example, for lookups or for anything. But it's not very generative palette, because all of these values are manually and predefined, and we want to have something different. We want our palette to be created algorithmically. About 2 years ago, when I just started to make all the sketches and to work with TouchDesigner more closely, I found this very nice talk of Lieberman, who is very famous in generative art and mostly in open frameworks community, and he very often used this kind of palette, from bluish to orangish. Very nice, very aesthetically pleasing, I would say. and how it's made. By the way, this super simple example I made a long time ago when I didn't know anything about GLSL and I barely understand it. So what I did, I used Python. I just watched this his speech, and you could watch it by yourself as well, very interesting, and grab the formula he uses from there. For creating the circles and calculating the position, there is some formulas, but we're not interested in it right now because we're interested in colors. And here is color for our color variation, color palette for our circle. And if you see the R, G and B channels, it's mostly the same. The difference is only in this coefficient, which increments a little bit from red to green and to blue channel. Just a tiny difference. And this tiny difference creates a very nice palette. And to make it dynamically, you add some dynamic variable like apps times second. And even if you don't like GLSL and don't like Python, you could do it without any coding, well, in visual coding, like in TouchDesigner. And here the example I did yesterday. So remember this coefficients, this small coefficients. Here I have almost the same, multiplied by 10, multiplied by 11, and multiplied by 12. And then I add a time. And here I have a math sine function. And here I have the same in top, the sine function applied to every R, G, and B channels. And then it was rearranged from a -1 to 1 because it's sinus to range from 0 to 1 by multiplying and adding 0.5. And we have here and here almost the same palette. The coefficients is a little bit different, but overall the colors about the same. But in my opinion, to understand how it works, it's even more difficult to understand when it's made in tops than understand it in Python or in GLSL, because if you have just one line of code, sometimes it's simpler than just switching between a lot of tops, a lot of nodes. So let's move on. And here we have again almost the same palette, but made in GLSL. And by the way, it's made by Inigo Quilez. Inigo Quilez is a well-known master of GLSL and creator of Shader Toy, and he have this old article from almost 20 years ago, well, more than 20 years ago, with this idea how to use the cosine. It's about the same as using sine, as you understand, to create these generative colors. And the second one is very similar to Zach Lieberman colors. And as you could see, it's again the small increments of a coefficient for R, G, and B color. And here's the Shader Toy implementation of it, but it's not very easy to use in TouchDesigner because you will need to select a specific row. So what I did instead, I did it like this. Here's the table with these 7 palettes, and you could pick the palette you like here, and it would be transferred into variables here. Uh, Again, we have a time and a frequency. If you don't want to move your palette, you could set time, or if you want, for example, start it from a dark, you could shift it a little bit. And instead of using the predefined variables, you could type it by yourself. And if you look closely, well, maybe it would be easier to look here. If you look closely, the first two palettes for the most of the first two variables, the first two columns, it's about the same. It's 0.5, 0.5, 0.5 everywhere, except the last string. It's a little bit different. And this again 0.5, and here in most examples just 1. So, which means that the biggest effect will have the palette number 4. So if you want to experiment with this idea, with this color palette, I recommend you to start changing the values of the palette 4 and maybe turn on the time and maybe increase the speed a little bit, so you could easily see the whole palette and decide did you like it or not. So you could try to find some nice color variation or use some of predefined one from here. And also I want to point a little bit difference between this example and all of that, because here I used the triangle wave function for creating this t variable. What is t variable? T variable is the variable that would say which that would pick the color. And here the let me show it here. And here this variable t is mostly affected by this vuv.s, which means the horizontal position. So the t would be different from this part to this part of top. But for example, in the case of particles and the particle speeds, instead of using just the horizontal position, you could insert the particle speed here, or you could insert the distance from a camera here, or some of remarching distance here, or anything. And that's why sometimes to have this palette inside GLSL is better than having it connected. So you could use not only vuv.s but something different. And here I use a triangle wave. So the t, this t would be looking like a triangle function, which is here. So we have equal chance for every of color. While here it uses a sine or cosine function, and the same in Zach Lieberman example. So it's a little bit of smoothness. It's not an equal distribution of the colors. And you could use different smooth and shape functions, and you could it would be a very nice exercise for GLSL beginners to go into book of shaders, to shaping functions, and to try to implement not the triangle function, not the sine function, but some other function. It's quite easy exercise, but probably with the other wave function you will achieve some interesting result. So, okay, let's move on. And here the Inigo Quilez used just a cosine function. So let's move on from the article from 20 years ago to the article from a couple months ago called band limiting. In this article there is a very nice example why sometimes it's some not very common situation, but sometimes using just a cosine function it's not the best scenario. I'm not sure that when I upload this video to YouTube that compression algorithms would allow you to see the difference between this part and this part, so it's better to go on this page and see it by yourself. But here on cosine version there is much noisier image and you have ugly moire patterns happening over here. While here in filtered cosines function there is no such problems. And as well as if you want to more deeply understand the math behind these palettes, you should read this article, and the same if you want to better understand how it's organized, you should read these articles. It's much better other than me explaining it to you. So the formula becomes a little bit more difficult, and here I have implementation. Here, not this one, here I have implementation of this idea. And this taken just from this example. Here we have 7 different colors, 8 different colors and 8 coefficients, so it's a little bit hard to understand. So here I have a simplified version with just 2 colors. Let's compare this example with this example. There are several differences going on. In previous example, we have a palette 1, 2, 3, and 4, and most of the thing happening in palette 4. Here, instead, it's organized a little bit different. You mostly need to pay attention to this code. We start from one color, like here we start from the palette 1, and then add another color. So here we add another color. The first color here is just again 0.5, 0.5, 0.5, and it's most of the cases a good start. You don't need to change it, at least when you start experimenting. And then you have 1, 2, 3 or 8 or whatever you want additional colors added to this one. So here we have, in the previous example, we have only 1 additional colors. Here we have 2, but you can add more and more and more. And how it's made, it's the palette 2, which is most of the time again the same 0.5, and here I have the coefficient 0.5 because here is multiplied by cosine and here is my coefficient, second one, multiplied by f cosine, which is this nice smooth and filtered function for cosine, and multiplied by 2 pi, and by second color and another coefficient. So here in this and this example, mostly you'll need to experiment with the color. You could do it manually, or you could do it like this in top. And for example, if I said 0.506 and 7, again I will have something very similar to the Lieberman palette we've seen before, because it's again a small incrementation from R to G to B. And the second color, it's not used because the coefficient here is equal 0. If I increase this coefficient, the more this coefficient, the more influence of a second, or in this case the third and fifth and so on palette. So this is a second example how you could experiment with generative colors. And here we have an example in Shaded Toy and in GLSL, but I also did almost the same example in Lookup, because in TouchDesigner we have a Lookup top, which is commonly used for colorizing something. And let's see into comparison between GLSL, between these smoothing functions and the Lookup top. Again, I'm not sure that YouTube comparisons would allow you to see the difference very nicely, so probably it's better to download this file and see the difference. But again, here we have a lot of more glitches, and here we don't have it. It looks much smoother with GLSL rather than in Lookup. And this is the second reason why sometimes it's better to have your palette inside GLSL, not connected as a ramp. And also the nice bonus is that if you, for example, if you have a noise and your noise goes from some values below 0 to some values above 1, Lookup doesn't works well or nice, because everything above 1 it would colorize in one color, everything below 0 it would colorize in another, while this GLSL example do the transition very smoothly, because it doesn't care about the input values. It doesn't need to be between 0 and 1, it could be anything, because the same as in these examples, as you could see, this value, for example, this horizontal pixel position, this value goes from 0 to 1, but it's multiplied and we add U time, which is super big one compared to this one. So the overall formula, it doesn't need to be between 0 and 1. That's why it works. So probably that's it. That's all I wanted to show you. Oh, one more thing. Maybe sometimes you don't need the whole gradient, but you need 5 or 4 or 6 colors. So maybe some of you already used the limit and quantize function. Here in the limit you also have the same in the level, but in case of these ramps, no matter which, this one or this or this, the level wouldn't work very nicely if you apply step in here. There is let me stop the animation. You have something strange going on. It's not look like expected. That's why in this case you need to use the limit and not the quantized value, but quantize the position. Quantized position. I prefer to use the floor or the ceiling, so I have the same width for every other color. And for example, if I need 6 colors, here I have a nice palette which can be used in many situations. I could even try to use this one, and again this quite nice colors. Well, maybe not this one. Okay, this is nice looking palette. So you can try to find some palette you like, even if you need just several colors. For example, I need 4 colors. And that's how you could create a generative palettes. And how to use it, we will discuss in the next tutorial. And I remind you that you could download this example from my Patreon. It would be available for everyone. But if you want to be one of my Patreon supporters, you're very welcomed. It motivates me to do more tutorials. And there is also some bonus for patrons, some more examples and other stuff. And that's it for today, and see you next time very soon. Bye bye.